basically, we use the sum and difference identities to help find the exact values of things that don't, like, appear on the unit circle. So, like, on the unit circle, we have, like, when it goes around, you got, like, 0, 30, 45, 60, 90, and those values. But this allows us to find the values of things that, like, kind of fall in between there. So, for example, like the example on page 113, it says find the exact value of the cosine of 15 degrees. So if you look at the sum and difference identities on your sheet, basically what we want to do is we want to write 15 degrees as either like a sum of two angles or like the difference between the two. So like we're going to look at the numbers we have on the unit circle and pick two of those that will either add together or subtract together to give you 15. So like 45 and 30, right? So because 45 minus 30 is equal to 15, right?
35 minus 30 is
45 minus 30. So we're going to rewrite it like this.
Why?
Because
Did you do like 55?
No, because you want in this part you want stuff that is on your unit circle.
Wait, the numbers 40 and 5 and 30 are
Yeah.
Okay.
So then if you look at...
Could you
Go ahead.
do like 225 minus 210? Or
You could, yeah.
so you want it to be, but you want it to be like the smallest number.
It doesn't really matter, but
The number that would be.
it's just easier to work with smaller numbers.
Any number that would pretty much give you the answer to what you need.
Yeah, that falls on the unit circle. Yep. So you can do it however you want. It's just as long as the numbers that you get here are on your unit circle. So if you look, our sum and difference identity for cosine looks like this. I'm just going to copy. So it says it's cosine of alpha. So basically what this means is the first number is going to be whatever alpha, 30 would be beta. And since we have a minus sign here, we're going to have a minus here, which means it's going to be a plus in between the two. You just kind of follow whatever the sign is. So if it's a subtraction for cosine, you're going to have an opposite sign in the middle. So they don't necessarily mean plus or minus. You're just going to follow whatever sign.
Can I use these the ones?
Which ones?
Calculators? Or do you have a...
Oh, gosh, yeah. You can use those, or I have some in a bin here. Not cosine.
Hold on. Oh, so we're just. Oh, okay. No.
Wait, how'd you get the positive sign?
Because it's part of the formula.
But how do you know which one to use?
For cosine, you're always going to use the opposite sign. Like, so since the minus is on the bottom here, then you want to use whatever sign's on the bottom here.
I don't understand how you got. I don't understand how you get the sign like the.
This
Yeah.
or this.
The actual sign.
So for cosine, for the sum and difference identity for cosine, if you have a minus, if you're subtracting your angles, then you're going to use a plus sign in the middle.
What happens if you were adding?
Then you would use a minus here.
So is it just coincidence that they're both on the bottom?
No, they're there that way for a reason.
Okay.
If you are subtracting angles.
For cosine. Now, but that's only for cosine though. Because if you
are subtracting angles for cosine, comma.
Then you're going to add over here. You're going to just follow the sign on the bottom. Or if it's on the top, then it's on the top. you change the sign. But if you look at the sum and difference identity for sine, it's going to keep the same sign.
So for these, you got cosine 45 times cosine 30 plus sine 45 sine 30.
Mm-hmm.
Is that what you do? You change it from cosine 45 to square root 2 over 2?
Yes.
Times square root 3 over 2?
Wait, what do you mean it stays the same for sine? Like it.
If it's positive, then it's if it starts with a plus, then it's going to stay a plus. If it starts with a minus, it's going to stay a minus. So yeah, the cosine of 45 is the square root of 2 over 2. Cosine of 30 is square root of 3 over 2. And then sine 45 is also the square root of 2 over 2. And the sine of 30 is 1/2. Right, and that all comes from the unit circle. So then when we multiply
45.
the square root of 2 times the square root of 3, we get the square root of 6 over 2, and then we get the square root of, over 4. And then square root of 2 over 4, so then we can just write that as square root of 6 plus square root of 2 over 4.
$120 plus 4.
And so then at this point, we're plugging in
Sine
120
45.
cosine.
And then sine 120.
Yeah,
This is easy.
it is.
Yeah, with the formulas.
Oh yeah.
Especially that we can use the circle.
Yeah, it is nice.
The circle.
The only ones of these that are even remotely tedious are the tangent ones. We'll do one of those next. Just because the formula is a little bit more complex, but overall it's not bad.
It's very rude of you to make us do a tangent one.
Well, sorry. So what's the sine of 120 degrees?
It's
Square root
negative
of
1
3
half.
over what? 2. Those are very different.
Negative 1 half.
Square root of 3 over 2.
Wait, what?
Are you sure? It's the second coordinate.
We're doing
The
sine.
coordinate of 120?
Sine of 120.
Sine of 120.
I got them switched.
Oh, I got them switched. You're right.
Square root of 3 over 2.
Oh, it's square root. It's negative 1 over 2. Stephen was 100% correct.
Are we sure?
No, He's right.
I said that when it was negative 1/2 too, so I don't know that I trust your.
Do it.
Where did you get negative 1/2?
It's this.
That's the cosine.
Oh.
It's cosine.
So, sine of 120 is positive square root of 3 over 2. Cosine of 45 is square root of 2 over 2. Then we've got negative 1/2
Plus negative 1/2
Oh.
times.
sine 45, which is
Ariel, what? No, wait, stop. Stop.
square root of 2.
Stop. All you're doing is confusing things. Poor Zach is going to watch this video and not know what the heck is happening.
Oh, is he? Are you recording?
Yeah,
Oh, sorry.
I recorded that whole mess of. That was where I remembered to start recording right before that. So that's basically like for this problem, that's what he's going to hear. Hi, Zach.
Sorry.
Hope you're enjoying this. Okay, so then we multiply. So the square root of 3 times the square root of 2 is the square root of 6 over 4.
Negative 1 times the square root of 2?
We're not there yet.
Well, you were right here.
I did negative. No, it's not negative. I did the square root of 3 times the square root of 2 is the square root of 6 over
Yeah,
4.
I just did that, but I'm talking about.
Why
Oh,
is there a negative 1/2 and still a plus in the middle? That's what I want to know.
There's not. It's technically a minus. So we're subtracting the square root of 2 over 4.
Okay, that makes way more sense.
I got distracted by Ariel shouting out things and I couldn't figure out where she was, but now I'm following.
Is that 3 over 4? Square root of 3 over 4?
2. That's a really terrible 2.
Can we not do square root of 6 minus? Oh no, that's completely different.
Alright, so we have tangent of 165, so we'll go ahead and write that. We'll use our 120 and 45 again. So tangent 120 plus 45. So then our formula for tangent, So we have tangent alpha plus beta is over 1 minus so then this would be tangent of 120 plus the tangent at 45 over 1 minus tangent 120 times tangent 45. The tangent at 120.
Square root of 3. Negative square root of 3.
And then tangent of 45 is 1. And we have 1 minus negative square root of 3 times 1. So we have, I'm going to like swap the order of this just because I like to write the square root. So 1 minus the square root of 3 over 1 plus the square root of 3. So, what do we not like to leave in the denominator of fractions? Square roots.
Don't those just cancel out and make a 1?
No.
Because one's 1 minus and one's 1 plus.
Right.
If
Then
they
one
were the
divided by-
same, it would just equal 1, wouldn't it?
Mm-hmm.
You can cross out the square roots though and just make it 1 divided by 1 is 1, right?
No.
Is that not
Because you're adding them together. You're adding the square roots on. If they were multiplied together, yes. But you can't just cancel out individual pieces of stuff that's added together.
Is that a 1?
Yeah.
Like just a regular one?
Yeah, my parenthesis got like a little wild there. So that's a negative squared.
Which one she was talking about?
Because I was also confused at what it looked like.
Nobody got my joke. How did you know which ones she was talking about?
Maybe because you're not funny.
Oh.
I'm kidding, Ariel.
Is this where you times it by the negative square root of 3?
Almost. So basically we're going to multiply it by the conjugate. So where we change that sign in the middle. So we're going to multiply the top and bottom by 1 minus the square root of 3.
Yeah, I knew it was something like that.
And then we have to FOIL. Nobody ever listens when I tell them FOIL is never going to go away. Paige, is that you? So then on top, we get 4 plus 2 square root of 3. And on the bottom, we get a negative 2. So that is going to simplify down because we can divide out of 2. Negative 2 minus the square root of 3.